Okay, let's begin section 8.3, but let's recall all the methods we learned in counting. That's right. This was where we're headed toward, which is probability. But first we have to know how many we have of certain things. And we learned about a multiplication rule, where we multiplied the cardinality of a set 1 times the cardinality of set 2, etc., to get how many ways to choose one from each set. All right, then we learned permutations, and this one was good. I was going to put another P. I don't know why. And this had to do with a factorial, like 4 factorial is 4 times 3 times 2 times 1, and therefore the product of that is 24. And then we said, well, it is the order specific arrangement of a set or part of a set. So then we had, and for the calculator, we structure it as NPR, where N is the cardinal number of the set, and R is the size of the arrangement. Order important. Well, then we said, wait a minute, what if we don't want order important? Well, then we had combinations. And these were groupings, where order is not important. And that one has the same kind of structure. Sorry. And that was NCR, again with N being the cardinal number. Well, now we're going to use that with something we studied in section 7.4, which was basic probability. And what this does is it gives us our quantities of involvement, and then finding out the, I thought it was 7.4, about how much a chance of something is occurring. And I should say a specific. So I got this from the book. Right. It says, recall the basic probability principle in section 7.3. We also covered that one, and repeat it here. Let S be the sample space with equally likely outcomes, and let E be the event of the subset of S. Then the probability of the event occurring is written as P of E, and it is a cardinality of the event over the cardinality of the sample space. All right, so Again, we're looking at the listing of what we've learned in 8.1 and 8.2. And in section 8.1, we stated that there are two or more sets that are mutually exclusive, and if the count of how many selections of one element from each set is derived. And we talked a multiplication, and that was the cardinality of set 1 times the cardinality of set 2, dot, 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 to whatever gives us that quantity.